Okay, so if we ln both sides, we're gonna get ln in here, and then also, okay, let me change it over here. So ln e to the a equals to ln e to the b, and then we're gonna bring out a and b to the front because they both are the exponents. So it looks like a ln e equals to b ln e, right? And then we all know that ln e equals to 1, so that means that a equals to b. Okay, so then that's the result that we have in here. Okay, so let's talk about the example that we have in this page. The balance A in a saving account is given by this formula in here, what T is in years. Find the rates at which the balance is changing from when T equals to 20 years. Okay, so whenever you see the word rate, it means derivative most of the time. Okay, so what we're gonna do in here is that we're gonna take the derivative of this function, right? I mean, obviously, right? Like we learn how to find a derivative in this section. That's why we have to do the derivative. So I'm gonna do a prime in here equals to the derivative of this one. 5,000 is a constant, so I'm gonna bring it outside, and I'm gonna take the derivative of e to the 0.08 t. Okay, so the derivative of e is itself. So I'm gonna go ahead and copy and paste e to the 0.08 t. And on top of that, we have like chain rule in here, so I'm gonna have to multiply by the derivative of the power, or like the derivative of the exponent, which is 0.08 t, right? And the derivative of 0.08 t, it equals to 0.08. Okay, and if you were to input everything into the calculator, what do we get in here? Well, we're gonna get 400 e to the 0.08 t. Okay, and at the end, because the question asking us for when t equals to 20 years, right? So this is the second step when we have to plug in 20 to the equation, and it looks like 400 times e to the 0.08 times 20. Okay, if you input all that into the calculator, you're gonna get 1981.21 approximately, if you route into 2 decimal places. So this is the rate of change that we're looking for. Okay, and if you think about it, in the graph in here, it reflects the result. Why? Because usually the first derivative, I told you guys, represent the slope in here, right? And as you can see, the slope is positive, right? So we should have an increasing tangent line at the point 20 and its y value. Okay, so that's confirmed our answer. Okay, so now as for your part, what do we know in here? So let me put a green star in here before I forget it. And then of course, because it's at the rate, well, you also have to find the derivative, right? But then of this function where you have like v equals to blah blah blah. And then in here, okay, so this one in here is supposed to be just one slash. Okay, so let me rewrite the function here properly for you guys. It like v equals to 7955.6 e to the 0.0458 divided by t. Okay, so that's just like one slash. I don't know why it has like 2 slashes in there, but I will fix it. And eventually, make sure you plug in 35 in the v prime function, and then you're gonna get the rate that you're looking for. Okay, but as you can see in here, your rate is like flat, so I'm guessing you're gonna get a 0 when you plug it in, but I don't know. Okay, like if it came out not to be 0, well, we have 2 cases in here. You can either ask me for the explanation to match it up with the graph, or I can check for your work and then give you more explanation about how to interpret the meaning of the rate by then. Okay, and now the last page in here is optional, so I don't know why I didn't put up the key for this, but I will upload it. I will change it, and it's optional, so it's not going to be tested, so you guys don't have to worry about it. But if you want, just read it for fun, and if you have any questions, please ask me. Okay, thank you for your listening. Take care and have a great day. Bye bye.